Alright, so for today's physics problem, I have problem 50 from chapter 34, and it gives us this diagram right here. And it says that a 10 centimeter wide zero resistance slide wire shown in the figure, which is this wire right here, is being pushed towards the 2 ohms resistor at a steady speed of 0.05 meters per second. The magnetic field strength is 0.5 Tesla. So the question is, how big is the pushing force? So we know that the pushing force is going to be the same as the force exerted by the magnet. Now for just a bar magnet, this is going to be the current times the length of it times the B field. Now we don't really know the current right now, but we can solve for how much voltage is being exerted. So we can do E over the resistance, which will give us current, still times L times B. Now we're going to need to make another substitution for what E is, and that is the B field times the length times the velocity. That's the E that we're going to get over the resistance, which stayed the same, times length times the B field. So we just made this substitution right up here for E. And then combining all these, we get the B field squared times the length of it times the velocity over the resistance will give us the force. And here I plugged in what the numbers were. See, there's that, and that gives us a final answer of 6.25 times 10 to the negative fourth newtons. So that's how much the push force is on this exerted from the system. Alright, so the next question is, how much power does the pushing force apply to the wire? So now we're going to need to solve for the power. And we're going to be using the force that we just solved for. So we know that power is going to equal the force times the velocity, because that's going to give us watts in units. So here we got our force that we solved for already. That's 6.25 times 10 to the negative fourth newtons, and times the velocity, 0.05 meters per second, which will give us a power of 3.1 times 10 to the negative fourth watts. Now the next question, there's part C, which asks, what are the direction and magnitude of the induced current? Well, if we go back to our diagram up here, we can see that this B field is going to be decreasing. So it's going to induce a B field that's coming out towards us at the page, which is coming out. And then if we use the right hand rule and you curl your fingers, you're going to see, oh, the induced current is going to be flowing counterclockwise now. Because as you see, this is this B field is decreasing, so we're going to have an induced B field coming out at us. Curling your fingers, we can see that it's going to be a counterclockwise current. So now we know the direction. Now we need to solve for the magnitude. So current equals BLV over R. And now just plugging in everything. Same numbers, nothing too difficult. Just plug and chug. We're going to get an answer of 1.25 times 10 to the negative 2 amps. Once again, that is counterclockwise. And there's just one last question this has, and that is D, which is how much power is dissipated in the resistor. So power, once again, is I squared times R, and we're just using that power that current that we just got, which is going to be 1.25 times 10 to the negative 2 amps, times R, which is 2 ohms, which gives us 3.1 times 10 to the negative 4 watts. And that's your final answer. So it's kind of a little bit of a tricky problem, but once you break it down and find those formulas, it's pretty simple math, nothing too complicated. Yeah, there you go.